Imagine you're a Royal Air Force pilot in 1940. A German fighter is on your tail. Bullets tear through the sky behind you. You push your Spitfire forward and dive to escape. But then something terrifying happens. Your engine coughs. It sputters. And suddenly it loses power. At the worst possible moment, the enemy fighter closes in. And the reason isn't enemy fire. It's a flaw hidden inside one of Britain's most famous aircraft. A flaw so serious it could mean the difference between life and death. Yet the solution wouldn't come from a massive redesign, a new engine, or a revolutionary technology. It would come from something astonishingly small. A simple metal washer. And behind it stood one brilliant engineer whose name is rarely mentioned today. This is the story of how a tiny piece of metal helped save the Spitfire, and perhaps even change the course of the Battle of Britain. A British fighter pilot has a German Messerschmitt in his sights. One more second and he could score a kill. He pushes his Spitfire into a dive. Then suddenly, the engine dies. The enemy escapes. And the reason isn't enemy fire. It's a design flaw hidden inside Britain's most famous fighter. A flaw so dangerous that it nearly cost RAF pilots their lives during the Battle of Britain. The solution? A tiny metal washer worth almost nothing. In 1940, Britain stood alone against Nazi Germany. The Royal Air Force was all that stood between Hitler and invasion. Its greatest weapon was the Supermarine Spitfire. Fast, elegant, deadly. But beneath its legendary reputation was a secret weakness. Whenever pilots pushed the aircraft into certain maneuvers, the mighty Merlin engine could suddenly lose power. German pilots quickly learned how to exploit it. And British pilots paid the price. Then an engineer named Beatrice Shilling stepped forward with an idea so simple that many people laughed when they first saw it. Yet that simple idea would help keep Spitfires fighting during Britain's darkest hour. This is the incredible true story of the tiny washer that helped save the Spitfire. Summer 1940. France had fallen. Much of Europe was under Nazi control. Britain stood alone. Across the English Channel, Adolf Hitler prepared for the possibility of invasion. Before German troops could cross the sea, the Luftwaffe needed to destroy the Royal Air Force. What followed became known as the Battle of Britain. Every day, hundreds of aircraft clashed above the countryside. The Spitfire quickly became a symbol of resistance. Fast, beautiful, deadly. Powered by the mighty Rolls-Royce Merlin engine. Pilots loved it. But hidden beneath its sleek exterior was a dangerous weakness. One that German pilots would soon discover. An exploit. RAF pilots began reporting something strange. Whenever they pushed the aircraft into a sudden nose-down dive, the engine hesitated. Sometimes it quit completely. Imagine trying to outrun an enemy while your engine is choking. That was the reality many pilots faced. German Messerschmitt Bf 109 fighters didn't suffer from the same problem. Their fuel injection systems allowed engines to keep running during negative G maneuvers. The Spitfire used a carburetor. During negative G forces, fuel flow became disrupted. The engine would flood. Power would disappear. German pilots learned this quickly. If chased by a Spitfire, they could simply push their aircraft into a sharp dive. The British pilot had to roll upside down first before diving. Those precious seconds often meant escape. Or death. Frustrated RAF pilots desperately needed a solution. But finding one wouldn't be easy. The Royal Aircraft Establishment worked a remarkable engineer. Her name was Beatrice Shilling. Friends called her Tilly. She wasn't a fighter pilot. She wasn't a military commander. Yet she possessed something equally valuable. A brilliant engineering mind. Tilly loved motorcycles. She raced them, built them, modified them. And she had an unusual talent for solving difficult mechanical problems. When reports of the Merlin engine issue arrived, many experts believed the fix would require a major redesign. That could take months. Britain didn't have months. The Battle of Britain was already raging. Pilots needed help immediately. Tilly began studying the fuel system. She searched for a simpler answer. And eventually she found one. Her solution looked almost laughably simple. A small brass restrictor. Essentially a washer with a carefully measured hole in the center. The device limited fuel flow during negative G maneuvers, preventing the engine from flooding, keeping power available longer. It wasn't perfect, but it worked. And best of all, it could be installed quickly. No major redesign. No factory shutdown. No months of waiting. RAF mechanics could fit it directly into aircraft already in service. Pilots soon gave it a memorable nickname. Miss Shilling's Orifice. The name spread rapidly through RAF squadrons. And so did the device itself. A tiny invention was about to make a huge difference. The first tests were promising. Pilots reported immediate improvements. The engine no longer cut out so dramatically during negative G maneuvers. Spitfires became more capable in combat. The Luftwaffe suddenly lost one of its advantages. Pilots gained confidence. Engineers gained proof. And commanders gained valuable time. The restrictor wasn't a permanent solution, but it bought Britain exactly what it needed. Time to improve. Time to adapt. Time to survive. In war, sometimes that's enough. Throughout 1940, the Battle of Britain intensified. Day after day. Raid after raid. The skies became a battlefield. Every advantage mattered. Every second counted. The improved reliability of Merlin-powered fighters helped RAF pilots stay competitive against experienced German opponents. Factories continued producing aircraft. Ground crews worked around the clock. Pilots climbed into cockpits knowing their machines were becoming more dependable. Many factors contributed to Britain's victory. Radar. Pilot courage. Industrial production. Leadership. Yet engineering innovation played a crucial role too. And sometimes innovation arrived in surprisingly small packages. Eventually, more advanced carburetor designs solved the problem completely. Technology moved forward. Aircraft improved. The war continued. But Tilly Shilling's washer had done its job. She had provided an immediate solution during one of Britain's greatest crises. After the war, she continued her engineering career. Yet her contribution remained relatively unknown outside aviation circles. Many people recognized the Spitfire. Far fewer recognize the engineer who helped make it better. But those who know aviation history remember her. And remember the elegant simplicity of her solution. When we think of World War II, we often imagine giant battles, powerful aircraft, and famous commanders. Rarely do we think about washers. Yet history is full of moments where tiny details change everything. A small piece of brass. A brilliant engineer. And a problem solved just when Britain needed it most. The next time you see a Spitfire soaring across the sky in a photograph or museum, remember this. Behind every great machine are people whose names rarely make headlines. People who quietly solve impossible problems. And sometimes, the difference between defeat and survival is no bigger than a washer. Because in 1940, one tiny piece of metal helped keep Britain's most famous fighter in the fight. And that's a story worth remembering.